Hi, John here. In this video, we're going to be looking at a coal-fired power station's water systems. Specifically, we're going to be looking at the condensate system, the makeup system, and the boiler feed water system. This video continues on from some of the other videos we created in the coal-fired power plant series, so be sure to check those out if you haven't done so already. So here is our drawing showing each of the main systems of a coal-fired power station. The systems that we're interested in are the condensate system, the makeup water system, and the boiler feed water system. These systems are shown on the diagram in blue, although the raw water system is also shown in blue. The condensate system on our diagram consists of a condenser, a condensate pump, a heater, and at the point the condensate enters the deaerator, the condensate becomes feed water. The makeup water system, usually taken from a lake or river or city water grid, is shown here and it flows to the deaerator. The boiler feed water system begins directly after the deaerator and it continues all the way to our boiler. In our coal-fired power station, this particular boiler is a water tube boiler. Let's start by having a look at the makeup water system. Makeup water is sourced externally from the power plant. It is water that you add to the condensate or boiler feed water system in order to make up for any water losses that may have occurred in the system. We can't just add makeup water to the system because the water needs to be treated first. It contains too much oxygen, too much CO2. We need to correct the pH level, and we also need to filter the water to reduce the number of total suspended solids and pass the water through a demineralizer plant. So there's a lot of stuff that needs to occur before we can add water to power plant system. Makeup water is often added to a deaerator where it can be treated both mechanically and chemically, although it may also be added to the steam turbine condenser. Let's now take a look at the condensate system, because as condensate flows through the system, it is then going to become boiler feed water. Condensate may be gathered at any part of the system and fed back to the deaerator or perhaps even the condenser. Condensate is water. Specifically, it is condensed steam. The steam that we created by a water tube boiler has given up a bit of its heat and it has condensed. Throughout the entire system, not all of the steam will give up its heat at the same time. And because of this, we'll need to have steam traps and drains throughout the entire system so that we can direct that condensate back to a storage area or a deaerator or the condenser. The majority of the steam is going to be condensed in the steam turbine condenser. The steam turbine condenser is installed directly underneath the low pressure steam turbine. By the time the steam reaches the condenser, it has given up the majority of its heat, and we've used that heat to rotate the steam turbine. Now, in order to return the steam back to the boiler in an efficient manner, we're going to cool the steam in the condenser and cause it to condense. When it condenses, we have condensate. On our example of a power station here, if we go around the back of the power station, we can actually have a look at the condenser which is installed underneath the steam turbine. We have our high pressure and intermediate pressure turbines here, and we have our low pressure turbine within this casing here. Steam from the low pressure turbine is exhausted to the space underneath the turbine, which is the condenser. After we've condensed the steam, it will gather in the lower part of the condenser in an area that we refer to as the hot well. That is this section around here. Once that has occurred, we'll then pump the condensate using a centrifugal pump. We can actually see that the condensate is being drained out through this pipe here and is going back into our power station. These other large connections that come along here, these are actually our cooling water lines. You can see them on this side. And if we zoom out, we can see that they connect to a cooling tower. and the water is coming along here. It's passing through the condenser along here and going back to our cooling tower. In this way, we can use the cooling water from the cooling tower to cool down the steam and cause it to condense. So we've left the condenser, we've sucked the condensate out of the hot wall area, and it's going to pass through a centrifugal pump. So now we're looking at a centrifugal pump. Specifically, this is a single stage overhung centrifugal pump. I'll pause the animation for a moment and I'll show you exactly how it works. The condensate from the hot well is going to be sucked in through this area here. It's going to go towards the eye of the impeller, which is the center point, and it's going to fill up this whole section, and then it's going to flow through the impeller outwards radially. If we push the play button on the animation, you'll see that the impeller is rotating this way. We're going to throw the condensate radially outwards from the shaft, and it's going to enter the volute casing. The volute casing surrounds the impeller, and it looks a little bit like a snail. The liquid comes around, and as it comes around, it's going to be discharged at the top of the centrifugal pump through this section here, and we're going to send the condensate through a heater or a series of heaters before it reaches the deaerator. Depending upon the setup at your coal-fired power station, you may utilize anywhere between 3 to 9 or even more condensate and boiler feed water heaters. These heaters are simply shell and tube type heat exchangers, and we're going to use them to heat up the condensate or boiler feed water in order to increase the process efficiency and not shock our water tube boiler. If we take a cross section, we can see that we have a fluid coming in on the left side. It's flowing along through the tubes, comes out here and comes back around and flows back the other way. We have another fluid which comes in through here and is directed around some baffles and drops down out of this nozzle here. So just have a look from another angle for those who haven't seen it before. We would have, for example, condensate entering through this lower pipe, flowing into our tubes, flows along the tubes to the opposite end of the heat exchanger, does a U-turn, flows back the other way. So we're going to go all the way over to the left here. And then the condensate or feed water, depending upon where in the system this heater is installed, will flow out of the heater. Meanwhile, the steam will be flowing into the heater, and it's going to pass through these baffles here that surround the tubes and drop out of this nozzle or pipe over here. If I take away the exterior, we can have a better look at the baffles. We'll come around the other side, and you can see the baffles, they surround the tubes. You can even take the tubes away as well. And these baffles are going to direct the steam as it flows across the tubes. The steam itself is going to be taken from our high pressure, intermediate pressure or low pressure steam turbines. You'll often see these heaters fitted in a cascade style system, and as the steam condenses, as it gives up its heat to the condensate or feed water, some of it will collect in the lower part of the heat exchanger, and we're going to drain that condensate off to the next heater, which is at a lower pressure, and we'll use the steam again to heat up the condensate or the feed water. In this way, we can make sure we're extracting enough heat from the steam as possible before it enters the condensate system and is treated and heated and turned into boiler feed water again. Another item that's installed on these heaters is a vent, and that allows us to vent off non-condensable gases, particularly CO2 and oxygen. So we've gone through our first heater directly after the centrifugal pump, but just remember there may be more than one set of heaters. On very large plants you may see 3 different stages of heaters: low pressure, intermediate pressure and high pressure. The condensate has been heated up by steam in our heater, and it's then going to be passed to a Deaerator. So here is a Deaerator. There are several different designs that you might have. Notice that the Deaerator itself is sitting on a raised platform. You'll often find Deaerators quite high up in power stations, and the reason for this is it gives the pumps which draw from the Deaerator a positive head of pressure. The pumps are often centrifugal, so they need liquid in order to be able to pump. They will not pump air. And for this reason, it just makes sense to sit the Deaerator as high up in the power plant as possible. Our condensate is going to enter through this inlet here. It's going to be sprayed out of a spray nozzle, which is represented by this section here. And we're going to spray it into this spray area, and it's going to drop down, and then it's going to gather in the lower part of the tank at about this level. And at that point, our condensate is now classified as feedwater. The tank itself is a boiler feedwater tank, although people will often call it a deaerator tank. We deaerate to reduce the number of dissolved gases in the boiler feedwater and condensate. You can see that steam enters the deaerator through this pipe here. It comes down the pipe and is then discharged through a sparge pipe or sparger pipe. Steam comes out here. We can see our yellow arrows. It will bubble up through our boiler feedwater. It will enter the top of the deaerator, and some of the steam will also rise up through this section here. Looks a little bit like a demister. And as it rises up, we've got a very large contact surface area between our condensate, which is being sprayed in, and our steam. And as we heat up that condensate, it's going to release a lot of the non-condensable gases, and we're going to vent those non-condensable gases and a little bit of steam through this pipe here, which is a vent. By removing the non-condensable gases, specifically CO2, carbon dioxide, and O2, oxygen, we're going to reduce the risk of corrosion. CO2 makes the water more acidic, and oxygen can lead to oxygen pitting and general corrosion. We may also add chemicals such as hydrazine to the deaerator, which is going to further reduce the amount of oxygen dissolved in the boiler feedwater. As I say, this is now our boiler feedwater tank, and we're going to draw out boiler feedwater through this pipe in the bottom of the tank. That's represented over here. Once we draw out the boiler feedwater, we can send it to a booster pump or series of booster pumps. Maybe we'll also pass it through another heater, a high pressure heater, and it will go then to our boiler feedwater pumps, which are multi-stage centrifugal pumps. So here is our multi-stage centrifugal pump. I'll explain to you exactly how this works. These are quite large items normally, and the reason is that they actually have to deal with quite high pressures. The reason we have to increase the pressure after the deaerator is because the water tube boiler itself operates with pressures exceeding 200 bar, which is about 2,900 psi. So we're working with high pressures, and when you work with high pressures, you need to have strong pressure boundaries. And that's why our boiler feedwater pump is quite heavy, quite bulky. It's because it needs to withstand these high pressures that it's going to create. So we fed our boiler feedwater in through this nozzle or pipe over here. It's going to flow downwards into the center of our impeller. You can actually see that over here. Once the feedwater flows into the center of the impeller, we're going to throw it out radially, much like we did with the single stage centrifugal pump, and we're going to throw it into a diffuser. A diffuser allows us to convert even more of the kinetic energy that we generated by throwing the liquid out radially into pressure. Once we've done that, we're going to repeat that process by feeding the discharged water from the first stage into the eye of the second stage impeller. We'll then throw the liquid out or in our case the boiler feed water out, radially. The impeller will convert some of that kinetic energy to pressure. The diffuser ring, which is stationary, this stainless steel item here, is going to convert even more of that kinetic energy into pressure. And we'll repeat the process by feeding it into the next stage impeller. This is our third stage, our fourth stage, and our fifth stage, which in our case is the final stage. We've increased the pressure at every stage. Once we get to the end, we have quite a high pressure. Remember, the boiler might be operating with feed water pressures in excess of 200 bar or 2,900 psi. And we discharge that boiler feed water up through this pipe, and then we can feed the boiler feed water then to our water tube boiler. So we've taken our condensate from the condenser, we've drawn it out using a centrifugal pump, we've then pumped it to a heater to increase its temperature, we've then sent it to a deaerator to increase its temperature still further, whilst also stripping out some non-condensable gases, and then we've then sent it to a boiler feed water pump and pumped it to our water tube boiler. Remember that typically you'll have more than one stage of heaters because you want to continuously increase the temperature of the condensate and the boiler feed water before it gets to your water tube boiler. The reason you can continually increase the temperature of the boiler feed water is because you're increasing the pressure. Remember that if you increase the pressure, then you increase the boiling point of a liquid. If you decrease the pressure, then you decrease the boiling point of the liquid. So knowing this, then we know we're going to be able to maintain a liquid state or a liquid phase, and we're not going to get that liquid flashing off to steam until we add a considerable amount of heat. And that's quite lucky because that's exactly what we're going to do when we get to our water tube boiler. Here is our water tube boiler. Let's take a cross section of the boiler. Now if we spin it around, we can see the internals. The boiler feed water is first going to be fed into this section of the boiler. The reason we feed it into this section first is because this is the coolest area of the boiler that we have. Combustion takes place in this area of the boiler here, the furnace. The exhaust gases from combustion, which are very hot, are going to pass along this way over here and down the opposite side, and they're going to come all the way down here, and then we're going to exhaust those hot exhaust gases, or now relatively cool, to our exhaust gas cleaning system, which we're going to cover in a later video. So our boiler feed water has entered through here. It's passed through the economizer. You can see it flowing through here. This entire bank of tubes is known as the economizer. And then it's going to be sent up all the way to our steam drum by going along here and across and to our steam drum. I'm going to stop the video at this point because round about now we're generating some steam. Not much, but that's what the rest of the boiler is for. In our next video, we're going to have a look at a coal-fired power plant's steam system. But specifically, I'm going to spend an entire video showing you exactly how a water tube boiler works. Hope to see you on the next video. If you want to learn even more about steam systems, water tube boilers, fire tube boilers, or engineering in general, then check out some of our online video courses. We've got over 30 hours of video content and over 25 different courses. So if you really want to expand your engineering knowledge, then please do check out some of our full courses. If you like this video, please feel free to like it or share it. It really helps us to produce more and more content. And if you haven't already done so, please subscribe to the YouTube channel. Thanks very much for your time.